All right, today we're going to pull back the curtain on the internet itself. We're talking HTTP Anatomy Explained, how the web actually talks.
So, have you ever actually stopped and wondered what happens when you type in a URL and just hit enter? I mean, what's going on in that split second? Is it magic? How does that web page just appear on your screen?
Well, spoiler alert, it's not magic. And it's definitely not just vibes. What's really happening is a brutally efficient, super structured conversation between your computer and a server somewhere out there in the world.
So how does that conversation even work? Well, like any good conversation, it needs a shared language. And in this case, that language is HTTP. You can think of it as the official rulebook for the entire web.
Yeah, HTTP stands for Hypertext Transfer Protocol. I know it sounds super technical, but its job is actually really simple. It's just the set of rules that make sure your browser and a server can talk to each other cleanly, without getting their wires crossed.
I love this analogy. Think about ordering at a restaurant. You don't just burst in and scream food, right? No, of course not. There are rules. There's a protocol. You look at a menu. You place a specific order. HTTP is pretty much that exact same thing, but for the web.
And here's the thing. Every single one of these web conversations, no matter how complicated they seem, boils down to a simple two-part structure. It's always a request and a response. That's it.
It's like a perfectly balanced back and forth. First, you have the request. That's your browser, what we call the client, asking for something. And then you have the response. That's the server, answering and sending back whatever you asked for. Super simple, kind of elegant, right? And this little dance is the foundation of pretty much everything we do online.
Okay, so let's get our hands dirty and do a little digital autopsy here. We're going to start with the first part of that conversation, the request. How does your browser ask for things politely so the server actually understands?
Well, a good, proper request has three main parts, and each one has a very specific job to do. You've got the request line, that's the core question. Then you have the headers, they give some extra context. And finally, you have the body, which is optional, but it's where you put any data you're sending.
All right, let's look at that first part, the request line. It is all about being efficient. Take a look at this example. Get/index.html http/1.1. It tells the server everything it needs to know in just three little pieces. Get is the action verb, it's what you want to do. /index.html is the specific thing you want, the where. And http/1.1 is just the version of the rules you're playing by. See? No wasted space at all.
Okay, next up are the headers. I love how the source material calls these metadata with attitude, because that's exactly what they are. They give the server extra info, like which website you actually want, that's the host header, or what kind of browser you're using, which is the user agent. It really is like showing your ID to a bouncer before you get into a club.
And then we have the body. Now, this part is optional. It's not always there. If you're just asking to see a web page, that's a GET request. The body's going to be empty. But if you're doing something like logging into a site, this is where all that data, like your username and password, gets bundled up to be sent over.
All right, so your browser has made its polite request. Now, let's flip the script. How does the server talk back? What does that look like?
You know the response actually has a really similar structure, and it's designed to give your browser everything it needs to know. It has a status line, it has those super important status codes, it's got its own set of headers, and then of course, the body, which is the good stuff you were waiting for.
So the very first thing the server shoots back is called the status line. It looks kind of familiar, right? Something like http/1.1 200 OK. This is the server's instant judgment on your request. It's basically saying, yep, got it, we're good, or uh-oh, something broke.
And that little number right there, the 200, that's a status code. And honestly, you can think of these codes as the emotional state of the internet. They tell you exactly how the server is feeling about what you just asked it to do.
So let's run through the greatest hits, right? 200 OK, that's the green light, success, everything's great. Then there's the infamous 404, not found, we've all been there. And here's a really important distinction. When you see an error in the 400s, like a 404, that's usually on you. You ask for something that isn't there. But if you see a 500 server error, that's on them. The server itself is having a bad day.
Now, just like the request, the response has headers too. But these aren't just extra info, they're direct instructions for your browser. For example, a header like content-type equals text/HTML is the server saying, hey browser, get ready, I'm sending you a web page, not a picture or a PDF. And these are absolutely crucial instructions, not just friendly suggestions. And finally,
We get to the main event, the response body. This is the whole point of the conversation. This is the stuff you actually see. It's the HTML that builds the page, the CSS that makes it look good, the images, the videos, everything. Everything else we just talked about, that was just the incredibly efficient postal service that delivered this package to your screen.
Okay, so you might be listening to all this and thinking, wow, this sounds kind of old. And you'd be right, it is old. But that's what makes it so important. So let's talk about why HTTP still matters so much. It's really all about new tech being built on these same solid old bones.
First, let's get one quick but super critical thing out of the way, HTTPS. What's that S for? It's for secure. And the best way to think about it is this. Regular HTTP is like sending a postcard. Anyone who handles it can read what's on it. HTTPS, on the other hand, is like taking that same message, putting it in a sealed envelope, and maybe even a locked box. It's the same conversation, but it's totally private and encrypted.
And really, this is the key thing to understand. HTTP dates all the way back to 1991. That's ancient in internet time. But its simplicity is its superpower. It's stateless, which means every single request is treated as a brand new independent event. And that simple idea is what has allowed it to scale to the entire planet. It's why all the modern APIs that run our phone apps, the cloud services we use every day, they all still speak this one fundamental language. Seriously, if you learn this stuff once, you can basically read the blueprint of the entire web.
So the big takeaway here is that the web isn't some kind of magic. It's machinery. It's built on a clear, logical, and surprisingly simple structure. And once you understand that structure, you start to see everything differently. I'll just leave you with this final thought from the source material. The internet rewards those who read between the packets.